Assalamualaikum and hi to Miss Fatima and all. We are from Group 4 and we want to present about the analysis of AMD Ryzen 9000 series. Let's meet the team. I am Azim binti Lokman.
And I am Nur Zakir Hanum binti Zabah.
Hello, my name is Umaira Dania.
So in this presentation, we will discuss about the introduction of the computer architecture and the introduction of the AMD Ryzen 9000 series, as well as the purpose of studies, architecture analysis, multi-core technology analysis, application categories, and also the conclusion to our findings. What is computer architecture? Well, computer architecture is the organization of the components that make up the computer system. There are three categories of computer architecture, which is known as microarchitecture, ISA, and also hardware devices. In 1945, a mathematician called John von Neumann has invented a computer with the basic computer architecture known as the von Neumann architecture. This architecture consists of several parts, which is CPU. The CPU contains of arithmetic logic unit, a register, and also a control unit or CU. And then the architecture also consists of input and output devices, and also a memory unit, and also a system which is known as bus system.
Diving deep into the impressive capabilities of AMD's latest processor series, which is the Ryzen 9000. The AMD Ryzen 9000 series is a significant leap in processing power. Built on the Zen 5 microarchitecture, it offers improved performance and efficiency, up to 60% better instructions per clock, and enhanced floating point units (FPUs), supporting AVX 512 instructions for faster, more efficient complex task handling. Double cache bandwidth ensures smoother performance in demanding applications. Integrated RDNA 3 graphic enables superior gaming and multimedia experience. DDR5 Mori support further boost overall system performance, optimized for AI workloads, offering up to 20% better performance in machine learning and AI tasks. The Ryzen 9000 series is a top choice for high performance computing.
Now let's move on to the purpose of studying the AMD Ryzen 9000 series. So the purpose of studying the AMD Ryzen 9000 series is to understand its technological improvement, evaluate its high performance compared to the other series, and to determine its influence on different applications. It also helps developers to improve software and games by utilizing the processor enhanced feature, such as a higher core count and improved efficiency. Researchers can study its energy efficiency and thermal performance to create sustainable systems, while businesses can analyze its market performance and economic impact. Overall, the analysis provides valuable insights for innovation, education, and practical application in technology. Moving on to architecture analysis. Here, we have the AMD Ryzen 9000 series chip. I will explain a little bit about the chip. So first, we have the core chiplets, which is known as CCDs. These are the rectangular blocks at the top of the chip. They store the Zen 5 CPU core, which is responsible for the main computational task. Each chiplet is designed for high performance and sustainability. Next, we have the input-output die, which is also known as IOD. This IOD is located at the center of the chip. This IOD manages communication between the CPU cores and external components. It also handles the DDR5 memory, PCIe 5.0 links, and other connectivity features. The last one, we have the power delivery components. The power delivery components surrounded by the core chiplets and the IOD. These components ensure stable power delivery to the chip, enabling efficient and reliable operation. Next, we have the AMD Granite Rich SoC. We'll explain 4 things about the AMD Granite Rich SoC. So first is the CPU cores. For the next diagram, we have the AMD Granite Rich SoC. Explain 4 things about the diagram. So first is about the CPU cores. Each core complex contains multiple Zen 5 CPU cores, which designed for high performance workloads, such as gaming, productivity, and data-intensive programs. These cores are highly optimized for multi-threaded workloads and power efficiency. Next is the 32MB L3 cache. A large shared L3 cache within each core complex reduces latency by storing frequently accessed data closer to the CPU cores. The 32MB per core complex ensure high-speed data access, which is critical for performance in compute-heavy applications. Next, we have the System Management Unit, which is SMU. This unit is dedicated for managing power states, clock speeds, and thermal performance, which ensure the SoC operates efficiently under verifying workloads. Next is Display Controllers. Display controller supports 4 simultaneously displays, which enabling multiple high-resolution monitors to be connected simultaneously. The DisplayPort and HDMI support are likely included, allowing for modern display standards such as 4K or even 8K output. Lastly is the Zen 5 microarchitecture. I will explain about the front end first. So the first one is the branch prediction unit, which is a two-taken stage. It uses stage, which is a tag geometry. Uses stage branch predictor accurate prediction of instruction flow by minimizing the pipeline stall. Next, it predicts the next instruction address, crucial for achieving high throughput. Next is decode, which is a 4-wide X2. It can decode up to 8 instructions per clock cycles. It also converts complex x86 instruction into smaller micro-operation for back-end execution. And lastly, for the front end is the L1 cache, which is a 32KB 8-way associative dual 32-byte fetch. It stores frequently accessed instruction data for quick retrieval. The 32-byte fetch ensures fast access to instruction data for high-performance workload. Now, I will explain a bit about the back end. First is the integer rename 8-wide. Renames the logical register to physical register to eliminate the bottlenecks and enable out-of-order execution. Next, we have the general purpose register 64-byte with 240 entries. This is the temporary storage for data and result during instruction execution. It supports high throughput with extensive register capacity. Next, we have the execution units. First is the ALU, which is Arithmetic Logic Unit. It handles basic arithmetics and logic operation. Next, we have MUL, which is multiply, a dedicated unit for multiplication instruction. Next, we have the BR, which is stand for branch. It processes conditional branches. Lastly, we have the AGU, which is Address Generation Unit. It calculates memory addresses for load store operations. Next is the NSQ96 entry. It handles speculative execution to maintain throughput even when branching prediction occur. Next, we have the load store queues, which coordinates memory operation, ensuring seamless data transfers between register and memories. Next, we have the L1D cache, which is a level 1 data cache, 48KB, 12-way associative, 4-read auto-write. It optimized for data locality with high bandwidth for reads or write, and it supports fast access to frequently used data. And lastly, we have the L2 cache, which is level 2 cache. It has 1MB and 16-way associative. It provides a larger storage capacity than L1, which serve as a mid-level cache between L1 and L3. The L2 cache reduces latency for data retrieval from main memory.
Okay, for now, let's move on to multi-core technology analysis for AMD Ryzen 9000 series powered by Zen 5 microarchitecture. Okay, this presentation analyzes the architectural enhancement in AMD's Ryzen 9000 series, focusing on the Zen 5 microarchitecture's impact on multi-core performance, power efficiency, and overall system capabilities. We will examine key improvement in clock management, integrated graphics, interconnect technology, power management strategies, and cache hierarchy. Okay, Zen 5 Precision Boost 3 represents a significant advancement over Zen 4's Precision Boost 2. Instead of a homogeneous clock distribution, Precision Boost 3 allows for individual core clock speed scaling. This dynamic approach optimizes performance by boosting individual cores based on their specific workload, thermal headroom, and power availability. This results in improved single-threaded performance while maintaining excellent multi-threaded scalability. The granularity of control allows for better utilization of available resources. Selected Ryzen 9000 series processors integrate RDNA3 graphics, creating a unified compute platform. This integration offers several advantages, which is improved graphics performance compared to previous integrated solutions, reduce system cost and complexity by eliminating the need for a discrete GPU in some applications, and optimize performance for hybrid workloads demanding both CPU and GPU processing. This is particularly beneficial for thin and light laptops and compact desktops. Okay, let's move on to bus system. The Infinity Fabric Interconnect, already a key feature of Zen 4, received further refinement in Zen 5. Improvement in bandwidth and reduced latency ensure efficient data transfer between cores, memory, and input-output devices, even under heavy multi-core workloads. This enhanced interconnect is crucial for maintaining high performance in large-scale applications where data movement can become a bottleneck. Okay, so now let's discuss about power management. Zen 5 enhanced power management through more sophisticated power gating techniques and improved dynamic voltage and frequency scaling (DVFS) algorithms. This allows for more granular control over power consumption, enabling individual cores or subunits to be powered down when idle. The result is lower idle power consumption and improved efficiency under heavy loads, extending battery life in mobile devices and reducing overall energy consumption. Okay, now, last but not least, we will talk about cache hierarchy. So, Zen 5 boasts a significantly enhanced cache hierarchy. The ultra cache size is substantially increased up to 128 MB, providing a significant performance boost for cache-intensive applications. Furthermore, optimization in L2 cache latency and improved cache currency protocols minimize data inconsistencies across cores, leading to more efficient multi-threaded processing and reduced reliance on slower main memory access. So, I would like to conclude for multi-core technology analysis that the Ryzen 9000 series based on the Zen 5 microarchitecture represent a substantial advancement in multi-core processing. The combined improvement in clock management, integrated graphics, interconnect technology, power management, and cache hierarchy result in a holistic performance improvement impacting single-threaded and multi-threaded workloads, power efficiency, and overall system capabilities. This makes the Ryzen 9000 series a compelling option for a wide range of applications from high performance computing to mobile devices.
Now we are going to continue with the application categories. As we all know, the AMD 9000 series uses the Zen 5 microarchitecture instead of Zen 4. So in this segment, we are going to compare the two microarchitectures. Now we are going to compare the both microarchitecture in real-time system. For Zen 4, it has single fetch or decode pipeline, has 6 byte dispatch of a pipeline, and 30% of gen-over-gen IPC improvement from the previous Zen 3 architecture. It is suitable for robots or drones and video editing. For Zen 4, it has improved branch prediction, accuracy, and latency, and has wider pipeline as wide as 8 byte dispatch and vectors, which can enhance higher throughput across the system. It has deeper window size across design for more parallelism, and it has increased about 16% gen-over-gen single-threaded IPC. It is suitable for gameplay, provide high frame rates across wide range of blockbusters and even esport, and perfect for 3D modeling, designing of animation, and product visualization, as well as the autonomous vehicles. Next, we are going to compare them in terms of embedded system. Zen 4 architecture uses the 5nm manufacturing processes. It has 13% of gen-over-gen IPC improvement, However, it has lower performance in heavily multi-threaded workloads as it needs a cooler to cool down the processor. It is suitable for industrial automation, edge robotics, and also IoT devices. Meanwhile, Zen 5 energy efficiency is increased because it uses the 3 nanometers and 4 nanometers manufacturing processes, which help AMD to reduce the power draw. The system on chip that came with it will have 15% less thermal resistance because it comes with an Arctic Liquid Freezer 3420 AIO water cooler, which helps to reduce temperature by as much as 7 degrees while maintaining the same thermal design power. This causes it to have longer lifespan. This way, more demanding tasks can be run while the embedded devices maintain lower energy usage. It is important for edge computing and Internet of Things devices as the battery life and thermal management are the main concerns. Lastly, we are going to compare them in terms of general computing. Zen 4 microarchitecture has improved the L2 cache size from 512 kilobytes to 1 megabytes per core, while L3 cache size is 32 megabytes per core. It is suitable for gaming and content creation and also watching movies, TV shows, and YouTube. Meanwhile, Zen 5 microarchitecture has improved the cache hierarchy by implementing new cache configuration with larger size of cache. L2 cache size is increased up to 1 megabyte per core, which makes it to be 2 megabytes per core. It reduces latency and optimizes data access, and it also improves applications response. It is beneficial for scientific and data analysis as it has fast access to large volumes of information in a single time. It is important for office work and gaming where data is frequently used by the user.
And last but not least, the conclusion for our presentation. So in conclusion, the AMD Ryzen 9000 series shows a great improvement throughout the year with the advanced GPU capabilities and an AI processing integration. The series set a standard for high performance computing while maintaining its energy efficiency. With the new Zen 5 microarchitecture, the AMD 9000 series is set to process more data workloads smoothly. With the new Zen 5 microarchitecture, the AMD Ryzen 9000 series is set to process more data workloads smoothly in any circumstances, whether it is a traditional workloads or the AI-related workloads. Due to its applicability, it can be applied in different contexts, such as gaming, multimedia production, embedded and edge computing. And that is all from us.